My review video is on the angle bisector theorem. The angle bisector theorem states that the side opposite of the bisected angle is in proportion with the adjacent angle. So, x over w is equal to y over z. This line right here is the angle bisector. All it does in this triangle is bisect the angle. It does not intersect perpendicularly, and it does not intersect at the midpoint. An in-class problem example that we did was on day 51, problem number 6. We were presented with a triangle, the angle bisector line here, this side length 3, this 4, and this 6. To set up the ratios for this, you put x and 6 minus x, and then x over 3 is the same as 6 minus x over 4. So you set them up and solve algebraically. The problem I created is similar. This is the angle bisector line. As you can see, it bisects angle A. And so I set up the ratio x over 8 is equal to 12 minus x over 5, because we know that AB is 8, AC is 5, and BC is 12. So then you can solve the equation algebraically. Finding the equation of an angle bisector is more difficult. First, if we have the bisector of angle A drawn in here, we have to find the measure of angle A before we can solve for this. So to do that, you have to drop in an altitude, and that way you can use tangent A is 8 over 6. So you solve for angle A, and angle A is 53.130. So that's the total of angle A, but you just need the slope of this line, and tangent is the same thing as slope. So you have to use this small triangle right here in order to find the slope of the bisector. So to figure that out, you divide this angle by 2, because this little angle right here is the same as that one there. And then you can solve for it, and you get tangent 26.565 equals y over 6, and then you end up with the slope equaling 0.5. And then you can use point A, and you can write out the slope of and the point. Using point slope form, you have the equation of the line. So y minus 2 equals 0.5, parentheses x minus 1. The example that I created is a right triangle, so it's a little bit easier because you don't have to drop in an altitude. If from point A to B is 5 and point C to B is 7, then you can solve for angle A using inverse tangent. So if you do inverse tangent of 7 over 5, you get that angle A is 54.462. Now, you have to divide that by 2 so that you can get this little angle here. And then I drew the triangle slightly bigger over here. Once you can solve for this, then you can get that the slope of this line is 0.515. So then using point A, you can write an equation for the line, which would be y minus 0 equals 0.515 x times x minus 0. Because tangent is the same as slope, you can solve for the slope of the line by dropping in an altitude, as I showed in the examples before. So tangent is the same thing as the slope. In an isosceles triangle, if you draw the angle bisector of the largest angle right here, then it will also be the perpendicular line in this triangle. So instead of having to draw in another height, the perpendicular bisector is the height in this triangle. So you can solve for the big angle, and then, like you did before, solve for the smaller angle and use tangent to find the slope of this line. And that's how you do the angle bisector theorem.